Okay, we're going to continue looking at the use of inverse trigonometric functions, but just to be clear, our basic three trig functions, sine, cosine, and tangent, are used mostly to find side lengths. Our inverse trigonometric functions are used to find angle measure. In this example here, you can see I have a right triangle. I'm given the hypotenuse as a length of 30, and depending on whether I'm talking about angle B or C, 24 is either an opposite or adjacent. So let's take a look at if I wanted to find the angle measure of C first, then 24 would be called an adjacent side. So what trigonometric function uses adjacent and hypotenuse? Well, the only one is cosine. So I know that the cosine of the angle C is equal to the adjacent side, 24 divided by 30. Now, you don't have to write that down. That's kind of messy. Let me see. Angle C is 24 over 30. You don't have to write that down, but that's true. So, but what I do want to know is to find the angle measure of C, I'm going to use the inverse trigonometric ratio, or function, I should say. So the inverse function for cosine will take me from the ratio of 24 over 30, and it'll take me back to the angle measure of C, all right? So I can use my calculator to do that. To do that, I would just take 24, divide that by 30. I'm typically going to get some kind of decimal. This turns out to be, wow, the same one in the previous video, 0.8. But this time I'm finding an inverse cosine, all right, inverse cosine. So I would go to my trigonometric functions, hit second, inverse cosine. There it is, 36.869, rounding off to the nearest hundredth, 36.87. So I would know that the measure of angle C is approximately 36.87. Now, once you have angle C, you can just subtract from 90 degrees to figure out the measure of angle B over here, which is going to be different. I do want to point out, though, that if you had wanted to solve for angle B first, or maybe you only wanted angle B, then it would make more sense to think about, let me erase this label, in relationship to angle B, 24 is the opposite side. Ooh, okay, that's different. That means when I wanted to find the angle measure of B, I would want to use inverse sine, because I would think, okay, the opposite side is 24 and the hypotenuse is 30, and I could go through the same steps. Let's take a look at a real life example, sort of real life. So in this picture, you can see I have a flagpole that's 25 feet tall. I'm at a position of 42 feet away from the flagpole on the ground. If I wanted to know any of the angles, you're like, why would that matter? Well, if you were measuring angles that had to do with shadows or time of year, or maybe it was a building or anything, there might be a variety of reasons of why you would want to angle. This one's a little bit contrived, but let's just go with it. If I want to find this angle measure X, notice that I'm actually given the opposite length of 42, and then this is the adjacent length of 25. Well, the only trig function that uses those two would be tangent. So I would use tangent inverse, all right, of my opposite side divided by my adjacent side, and it would give me my angle measure for the angle X. So using my calculator, let's see, 42 divided by 25 is kind of ugly, 1.68. That's okay. And inverse trigonometric function, inverse tangent, 59.24 rounded off. All right, 59.24 degrees. And I would know that that corresponds with that angle there. That's just in general what inverse trigonometric functions are for. They're for finding angle measures.